I'd like to welcome you to today's webinar. This webinar is part of our educational online event series brought to you by Ridge Systems and our partners in digital manufacturing. Our topic today is on leveraging design for additive manufacturing with Materialise, Matic, and Matic. My name is Robin Gonzalez, and in addition to being your host today, I manage the additive manufacturing sales for our strategic accounts here at Ridge Systems. Joining me today is an expert from Materialise, Evan Kirby. Evan is an application engineer and with an in-depth knowledge of additive manufacturing and how Materialise can help. For those of you new to Ridge, we've been providing engineering and manufacturing solutions to North America for over 20 years. As you can see, we have 21 offices and digital manufacturing labs across the country. In addition to products and services, we partner with the leading providers of engineering, manufacturing, and 3D printing solutions. So that is just a quick overview on Ridge. Now let's get to our topic today with Evan from Materialise.
Thank you very much. Glad to be here. Just want to talk to you real quickly about Materialise in general before we start with the meat of everything. And give you a little background of where we're coming from and kind of why we've partnered with Ridge and vice versa. So just an idea of who Materialise is, we actually started 30 years ago, and we started with a single SLA machine. And we've grown from there to what you see here. And you can see that we have a very large global presence. In fact, there's 27 offices in 20 different countries. We currently have over 2,000 employees. We're headquartered in Belgium. And that's where everything started. One day I was talking to our founder, Fried van Kren, and I was asking him about the SLA machine that he bought that started this whole thing. And he said that it was machine serial number 32. And the easy way to remember that is that's the same as the telephone country code for Belgium. And so I've never forgotten that to this day. I actually have been employed with Materialise since 2001, so I've been doing it for a while as well. I work out of our USA office near Detroit. We're in Plymouth, Michigan, and I actually manage the team of application engineers for all of North America. We, like I said, have been doing this for 30 years. Started in 1990. And when we first started with that SLA machine, serial number 32, we just needed to make it work because at that point in time, 3D printing, or at that point in time it was called rapid prototyping, no one really knew what it was, no one knew how it worked. And the data especially was a challenge, and we just needed to figure out how to take the data and marry it to the machine so we could start building parts. And I was hired in 2001, and we were just kind of finishing up that process. So it took, a good 9 or 10 years just to get that far to make it so it was something that we could make work and make profitable. So our next step from there was to do something to make it meaningful. And probably I would say the first big 3D printing success story is hearing aids. And I think it's somewhere around 90 to 95% of all the hearing aids made globally now are 3D printed. They really lend themselves to the process. The materials are right, the sizes are right, the resolution that you can get from the machines that make them, it's perfect. And since they're all custom devices, that is a perfect marriage of the high value, low volume, really, although it's not necessarily low, but it's custom, mass customization for manufacturing. And it really worked very well in the hearing aid industry. And in the course of about 5 years, it transformed the industry from doing everything by hand, and then about 5 years later, they were all being made by 3D printing. And so that's kind of the second 10 years, right? Or the second 12 years or so. So for the last, 3 or 4 or 5 years, we've been trying to make it worthwhile. and doing that by trying to support now distributed manufacturing, which is what Hawk Ridge is doing as well. And the idea there is then to, especially nowadays, right, with all the supply chain problems that we've had, make it so that we're more flexible in terms of how we're making our parts and making those goods that we need to make for the end users. And so we're concentrating now on making all of this worthwhile. And part of that is, getting together with partners like Hawk Ridge to make sure that we can reach out to as many users as possible. So just to give you an idea of where those 30 years have gotten us, what you'll see here is the fact that we're kind of everywhere. We're kind of everywhere. And I'm going to ask a question, then I'll start talking more about this slide. But one of my favorite questions to ask is, think of when people ask me, well, what do you do with 3D printing? And well, what I'll do is I'll ask them a question. Think about 3D, think about an industry where you would not find 3D printing. You just would never think that you would find 3D printing in that industry. So do me a favor, and if you can think of something, I'm just gonna take a look at the chat box here. Throw something into the chat box and or throw it up in the questions, and I'll just monitor this, and maybe you guys can stump me. And if I don't get any questions, I'll give you one of my favorite examples. So anyway, you can see here, we're kind of everywhere. We are really working with just about all of the large metal system manufacturers. Almost all the automotive companies use our software, and I know a lot of people at those companies. Then also the industrial system manufacturers in general, right? Additive system manufacturers in general, they use our software as well for some type of thing. And also the top 20 companies in the Fortune Global 500, they use it too. So I'm kind of looking here, I still don't have any questions, so that's okay. One of my favorite answers to that question is food. So people will say, well, what do you do in the food industry? And my first answer is Coca-Cola. Coca-Cola uses our software to help prototype the guts of those super whammadine Coke dispensing machines that you'll see at Five Guys, probably Shake Shack, those types of places where you have a bazillion different flavors of Coca-Cola. And I know the guy down there, know him really well, a good friend of mine. He goes through and prototypes the guts of those along with doing a lot of other things, but that's one of the things that he does with it. And now our partners. So these are kind of on the OEM side of the world. You can see that we're partnering with a very large number of machine manufacturers and in fact also other software vendors. You can see on here Siemens and PTC. They're actually using our technology in the back end somewhere to help with their solutions. But yeah, we're everywhere. I know we've talked with other software vendors as well, but yeah, and in fact this little blurb here from Stephen Nigro at HP, we're partnering with them, and that's something that you guys can talk to the fine folks at Hawk Ridge about to see where Materialise software fits with their 3D printing offerings. Okay, so now that I'm done with that, what I'm going to do today is that's it for presentation. I've been doing this for a long time. I'm a really hands-on kind of guy, and I really prefer to do live demonstrations over videos and presentations and that kind of stuff because it's what I do. It's kind of one of the things I did way back when I was in the Navy. And what we'll do here is we're just going to take a quick overview, kind of the purpose and the interface of Matic. and then we'll go from there, and I'm going to do some topology optimization results. So do some cleanup of the results of some topology optimization. And I do have a page on our website ready to go just to show you an example of someone that actually did something with this. Do some lattice work as well, along with some texturing, And then we'll open it up after that's all over for some questions and answers. So if you'll give me just a moment, I am going to go to, there we go, and we'll get back to it. Okay, so we're looking at 3Matic now. And 3Matic, it's a Windows-based program, so it has all those nice little Windows things. You can drag and drop functionalities. You can drag and drop parts to do intersections and different types of booleans and that kind of stuff. So it really is one of those things where if you're used to using Windows, it doesn't take all that long to pick up the basic operations of it. If you're used to using CAD, so I'm using, in this case, my right mouse button to do some rotation, using my scroll button to zoom in and zoom out, those types of things. It's all really generally applicable to a lot of the knowledge that you may already have. Now, when I look at the interface here, you'll see that I have a toolbar down the left-hand side. This is kind of the main toolbar. Has my most commonly used functions, importing parts, opening projects, undo and redo, those types of things. And then across the top, I have some drop-down menus. And then underneath that, I have toolbars. And in the drop-down menus and on the toolbars, I'll have functionalities that are grouped logically according to what they do. So all my marking tools are here. Anything that would be termed a design tool is here. And when we talk about design in 3Matic, remember, everything that we do in 3Matic, we're performing these operations directly on STL meshes. That's what sets 3Matic apart. We're performing CAD-like operations on STL meshes. So I can do revolves, I can do extrudes, I can do sweeps, I have surfaces. One of the things that makes 3Matic a little bit different than other STL operators is the fact that I can group triangles into surfaces. And because of that, I have the ability to perform different types of operations on those. All right, so also in terms of the interface, on the right-hand side, I have some panes. I have an object tree pane, and later on we'll see it's not just parts, but when we get to texturing, it's UV maps, it's sketches, it's all those other little items that are objects within 3Matic, but aren't necessarily, parts. And then down below the object tree pane, I have the operations pane. Right now, I'm not doing any operations, so this is blank. I do have, since this is the part that's actually selected, I have some properties for that. So this is always going to be a properties pane for whatever is selected right then, whether it be a surface or a part or a UV map, whatever it happens to be. And then down at the bottom, I have a log window. And the log window actually tells me a lot of good things. You can see that I've had it open for a while, and so it's telling me, hey, it did an automatic save for recovery if it crashes, that type of thing. All right. So the first topic is going to be that topology optimization. And what I mean by that is, let's hide this part. So I'm just going to right-click and hide. And what I have here, and this is a little bit translucent, and there's an opacity command right here. You can see transparency. What do you want it to look like? If I wanted to be completely opaque, it would look like that. We'll go ahead and make it go do that there. This is actually something that General Electric threw out there a number of years ago, and they were trying to get an idea of the capability of topology optimization at that time, because they were really looking at it. And this is one of the results that was performed and then we were able to obtain those results. So this is the design space that they used, and this is the original bracket, and you can see it's a big solid machined chunk of metal, and they wanted to make it lighter, and so they said, okay, all you topology optimization folk out there, we call it generative design now. I still call it topology optimization because I've been around for too long. And they said, these are the loading criteria, these are the performance criteria, go. And what happened after that is a particular, I don't know which package it was, but a particular package gave these results. So I now am going to take this and make it into something that we would actually, in this case, 3D print. The first thing that I'm going to do is do a little bit of defeaturing. And to do that, I need to just take some faces here. And if you're used to using Magic, so if you're used to using our Magic software, this is the same exact thing. I'm using a marking command to identify triangles for editing. The difference in Magics is they turn green, and through Matic they turn orange. And another thing that they have in common is I'm going to just make those and hide them. I'm going to make them invisible. And the reason that I did that is it allows me to use another marking command to mark some entities here. And there you go, all at once. And one of the ways I do that is it's called smooth region marking. And one of the cool things, and you can see now as I look in my operations pane over here, I can change how that's going to work on the fly. So this is one of the things I really like about 3Matic is I have that capability. And what I'm going to do with these, so the edit that I'm going to perform on these triangles is I'm going to delete them. And after I do that, I'm going to make them visible again. So there we go, looks like so. And just like with any STL file, now I have triangles that are missing. If we take a look at our properties of our part here, you can see that it's going to tell me that it has 12 bad contours with 448 bad triangle edges. So it's triangles. So I then go to my fix toolbar, and I'm going to use a function here. I could, if I wanted to, I could fill these one at a time. I'm not going to do that. We have a function in 3Matic called the mass hole filler. And basically what you do is in your selection box here, the entities, if you ever have a question about what entities you can put in this selection box, you just do F3. And when I do F3, it says, hey, you can do parts. Those are the entities that will fit into that box. The way this particular function works is I'm just going to say, hey, look at a certain number of bad triangle edges, and if it's this many triangle edges or less, make new triangles there. I apply, and it does. And you can see that these actually turn into their own surface. I can select that. You can see that that's its own surface, and it pops up over here in my object tree as that's that surface. Okay, I'm just going to deselect all because that was just a quick explanation. Now, this is cool. If I were playing Qbert, so that tells you how old I am. If I were playing Qbert, then we would have a really fun time with this because I have this nice pixelated look to it. But we're not playing Qbert. We want to make this into something that we can actually build. So what I'm going to do is I'm going to go to my design toolbar here and subsequently choose the wrap command. There it is right there, wrap. And again, what do you wrap? In this case, I'm going to wrap the entire part. And I choose a smallest detail here. That's basically going to say, what's the smallest detail I'm going to try and replicate? And then also on this particular part, I'm going to do an offset. And when I apply this, you'll see why. So there it is. And I'm going to go to, I'm going to collapse my tree. I'm going to just change the color of my, so go here and you just go to the color. Let's pick a different color. I want that one. There we go. That'll work. And this is the reason why I added a little bit of offset to that. And you can see what it did is it helps if I were to not put that offset on there, it would try and completely replicate those steps. And that's not what we want. We want it to be something that looks more like this. And so it kind of truncates in off those corners. Okay. Let's go ahead and hide the raw data. And we'll select the wrapped data. Now, this is, it's already much, much better, much, much better. But it's not good enough. So let's make it better. I'm going to go to Fix. And I'm going to go to this command called Smooth. I have a bunch of options here. I actually have found that this first order Laplacian smoothing with a smoothing factor of 0.7 works in probably 90% of the cases, and it works in this one for sure. And then you just do this a few times and you'll see it get much better. So I did it 4 times, that's probably good enough. And now it looks like this. At this point, I'm going to continue on, but I'm just going to do a quick breakaway. There we go. I'm going to do a quick breakaway to that case study I talked about, something that someone really did, and it's this one here. And this is actually a hydraulic valve. It was built on a metal machine, and this is the process that they used. They went ahead and so something like this if you're familiar with hydraulic valves or hydraulic assemblies, right? Some type of porting assembly, manifold, that's what I'm looking for. They're frequently just a block that gets cross drilled. So you drill all your holes and then you do a bunch of cross drills and then you plug your holes. And so it's expensive because you have to use an entire block of material and then you make your shavings and you break drill bits, all that kind of stuff. And it also, another thing about doing it this way, if we do this and we build this in additive, is maintenance costs are lower because this is a single piece. I don't have those soldered in plugs or just press fit plugs, that type of thing. So your maintenance costs are lower. And you can see what I have here on the left here. This is actually the result of the topology optimization. And then this is the cleanup result in Matic. And that's basically what I was doing with this other bracket, doing the same exact thing. So let's go ahead and continue on. There's our little nice little break from Matic. We're going to continue on with this. And what I'm going to do now is I am actually going to do a Boolean intersection, because you can see that I defeatured the part. Well, I need to get those back. So what I'm going to do is I'm going to grab the design space. I don't have to show it, I will, but I don't have to. There's the design space. And you can see that both of these, when I went to Boolean intersection, and it's right here, Boolean intersection, grab the design space. And when I do that Boolean intersection, that's the result that I get. There's the result. Beautiful. Beautiful. And this is something that I would say, hey, I can actually manufacture this. This is something that I would be happy to manufacture. Now, I can either stop here, it depends on what I need, or there are a few more. I'm just going to show you one more item here for a little bit of cleanup that we can perform. You can see that the radii that I have here, they're not all that great in terms of their surface quality. So I'm actually going to do the top two. And what I'm going to do is I'm going to go back to my fix toolbar, and I'm going to say project mesh. And then when I project mesh, again, what entities do I want to do? In this case, if I just left click, it's going to say, okay, do I want to do the whole part? Do I want to do this surface or the surface from the design space? I'm going to do this surface right here. I can actually do this surface over here at the same time, since they're basically the same radius. And you can see what I'm doing here. If I choose the method down over here, it's saying, okay, these are the objects to which you can project this mesh. In this instance, I want to use a fitted cylinder, and it's going to fit in an analytical cylinder to those surfaces. And you also always want to subdivide. I'm actually going to show right now, I'm going to come over here and I'm going to say, hey, let's take a look at the triangles. And you can see this is the current triangulation. And the problem here, the reason that it looks like it does, is because the triangle facets are too large. I need to actually make my triangle edges shorter so I can have smaller triangle facets. And when I apply, and that's what this subdivide and number of iteration does. So when I apply, you'll see that's what it does. Okay. And now let's go ahead and take a look so we can really see it. It looks like that. I'm going to go ahead and deselect, cut it out, deselect that surface. And they look like that. Beauty. Okay. I'm going to just come over here and right click. Lots and lots of context menus in 3Matic. You just right click and it's going to say, what do you want to do? Just like you would in other Windows programs as well. If I select a surface like that, I'll get some other context menus. Now that I have a selected surface, I get a different context menu if I right click in the workspace. So all kinds of things that I can do here. All right. And one of those things, I'm going to right click on this part and I'm going to duplicate it just to save it for later, just so I know that I have one. And then I'm going to hide it. I don't necessarily need it, but there's two of these now. Real easy way to duplicate an STL file in 3Matic. Okay. The next topic is going to be lattices. And this is something that's actually really hard to do outside of the STL environment. And STL files, because of their nature, actually really kind of make it easy. So I'm going to select our part here, and I'm going to go to my lattice tab, and you can see there's a whole bunch of operations here. You know, if you guys decide that you want to indulge in 3Matic, then we'll certainly be happy to, along with Ridge Systems, you know, figure out some training for you guys. That's for the future. And I am going to perform a unit cell based lattice. And you can see again, where do you want to put this lattice structure? And I'm going to put it in the results of the intersection. Now I need a unit cell for this. This is a unit cell based lattice. So what I do is I'm going to come up here and I'm going to import. And one of the cool things that we have in 3Matic, if I just go back a menu, is we have a couple of things. I have a unit cell library, and later on we're going to see this as well. I have a texture library. So in the unit cell library, we already have some canned unit cells. One of the most popular unit cells is a dodecahedron. It's popular because it displaces load evenly across its geometry. It can be self-supporting as required if it's properly oriented, those types of things. So and it's a really nice unit cell. Now what you'll see here, this particular unit cell, what we're looking at is actually an emulation of if this unit cell had a 0.5 millimeter diameter. Now I'm going to come down over here to this button on my main toolbar right there, and I'm going to turn it off. And this is what it actually is. It's actually just a bunch of graph lines. Just a bunch of graph lines, like so. And we're going to replicate that throughout the volume of our part. To do that, you can see I'm working on my unit cell based lattice. To do that, I'm going to go into the properties, right, in my object tree of that dodecahedron, and I'm going to find the graph of it. And there it is right there. I'm going to find the graph. Down here, you can change what you want that size to be. And something that you'll see, and this is where the log window comes in really handy, at this unit cell size, so this is in millimeters, mind you, 3.46 millimeters, at this unit cell size, this is how much RAM it's going to require to do that. Now, I don't want this to take a really long time, so I'm going to bump that up a little bit. And something else that you'll see here is, since it's uniform, I don't have to fill out the rest of these. I can just go on with my life. If I tell it, right, if I turn off keep aspect ratio, then I can stretch it out if I want to. Another thing that you can do down here is the fill. If I choose to do solid, all I'm going to get is a body of the lattice. It's going to fill up the volume of the lattice, and it's going to get rid of the outer surface. I can keep the outer surface if I want, if I tell it to remove the, later on, if I tell it to remove the original. So if I want it to be hollow, if I choose it to be hollow, then it's going to tell me, hey, you're going to need to define a shell thickness for that. In this case, I'm just going to do this completely as a lattice. We'll click apply, and whoop, it's done, just like that. There it is. You can see this is what it looks like. I have, like I said, I have a whole bunch of options up here. So some of the things that you'll see is I can filter out some of these small things that aren't connected to anything. Now, they actually are going to get connected, and I'm going to show you how. So at this point, I can turn this into an STL file, but I actually don't have to. Basically, what I can do is if I simply go to convert lattice to mesh, right? And I say, all right, let's go get that graph. There it is to populate in here. If I tell it to use existing thickness, and then I just save this as a 3-matic project, I can actually load that into Magix, and it never makes an STL file out of this. And the advantage to that is if you have a Materialise build processor, the build processor then, as it slices, will add that contour to each strut of the graph. And you never make an STL file because these get really heavy. If you don't have a Materialise build processor, well, then you do this. You say, all right, let's go ahead and add a thickness to it. In this case, I'm going to use 1.5 millimeters. I'm going to use the smaller the accuracy number, the smaller the triangle edges, the more triangles you get, the smoother it gets. I'm just going to use this right here. You can see it doesn't use much memory. Apply, and it's going to finish up real quickly here, and it will look like this. And there it is. And you can see even down here, since I added some thickness to that, it joined those little floaters together. So I do have, if I wanted to do it this way, I do have other methodologies where I can go and filter out small pieces after the fact. Not going to worry about that now. We only have a certain amount of time with this, but there's a nice lattice for that entire part. All righty then. So let's go ahead. I'm going to collapse my tree again, and we will hide this one, and we're going to go back to, we'll just snag this one, show, right? The last thing that we're going to do is we're going to apply a texture. This is another thing that is reasonably difficult to do in CAD. So if I can do it here, great. The first thing I need to do with this is make a UV map, because the way that our texturing functionality works is with images. And I need to define where those images are going to go. And I'm going to use, remember how I made these two surfaces look really nice? Those are the surfaces that I'm going to use. So create UV map. And then you can see the entities, right? So I just click here, I click that surface, I click here, I choose that surface. They both populate into here. If I were doing if I were going to put this around a cylinder, then I would need to define a seam where this image is going to begin and end. That's what that's for. I'm not doing that this time, but that's what that's for. And really, that's all I need to do. And then I can click apply. And there it is. There it is. You can see that's what it looks like. When I get to this part of the functionality, what I do now is I can come up here and I can translate it if I want to. You know, I can move it around, you know, do whatever. I can rotate it. I'm not going to because I really like the alignment of it, but I can if I want. I can also do this though. If you can see, since it's selected, and I'm doing rotate right here, I can say rotate by 90 degrees for my step size, and then it'll only, boop, it won't rotate until I hit 90 degrees. So do that many times and it's back to where I started from. So I can do that as well. The last thing I might do on this is, wrong button. Resize it, get the right button, there it is. You know, make it bigger or smaller. And really what you want to look for is the size of the checkerboard, because that will then determine if I make it bigger like that, actually I'm going to get more pixels per square millimeter now. There you go. When I go to actually apply that image on there. All right. there's an exit button on here. I don't have to exit. I can just really just go to my next command, which is go to texturing, go to the texturing toolbar and say, okay, let's apply a texture to these surfaces. So the UV map, I can select it just like that. I can go to my list and grab the UV map out of here. That's one more way I can do it. And again, just like with the lattices, I have a texture library. Now, I'm actually going to, at this point, just jump back out again. I'm going to go back to here. And one of the places where we do a lot of texturing, that people use texturing a lot, is in making shoes. And what they'll do is they'll make these shoe soles, and you can see they do a textured master for casting. And it saves them a bunch of time. Saves them a bunch of time. And so they apply all these textures onto the shoe soles with 3Matic. So it occurs to me that there's also another one. If you look through, I'm just going to go back one page. If you go to our website and you kind of go to find use cases for 3Matic, you can do a search and do use cases, 3Matic use cases. This is what you'll find. So you can go here and just see this is everything that people are using this software for. Lots and lots of different things. Okay, let's go back to 3Matic. And one of those things is actually Samsonite uses this to put a texture on their prototypes of luggage. And this is one of the textures that they use right here, this pyramid. And that's the one that I'm going to use. So we're going to click open. There it is. You can see it populates it into here, right? And I click apply. And now that texture, that image has been applied to both of those surfaces. If I push the escape button, just like lots of other things, you can see escape gets me back into the main 3Matic window, right? Okay, the last thing that we'll do with this, we do have functionality where you can do like we do with lattices, where you just save it as a texture with the amount of difference in height that you want, because that's how it works. It looks at the contrast between pixels and assigns a difference in height. That's actually on that last page. If I save this as a 3Matic project, again, I can use a build processor to apply it while it's slicing. Otherwise, you go here to 3D texture. I'm going to do both regions at the same time. I'm going to populate both regions. You can see this is 48 and 50. Populate both regions. And here's what I was talking about, white offset and black offset, right? So anywhere there's a white pixel, it's going to be raised 3 millimeters. If I have a black pixel, it's going to be at the same original height. I can inset that if I want to. This detail size determines how exact it's going to be to that pixel. Obviously, as I turn this detail size down, things get smaller and your memory requirement gets larger. This will be fine. It's not going to take long. We'll just go ahead and apply. And then we get this. And it looks like that. So if I turn that detail size down, I get more triangles, but this gets nicer and nicer. So that is the finished texture. We'll go ahead and collapse this. And with that, I'm going to turn it back over to Robin.
I really appreciate you taking time out today, Evan. Some really good information, fantastic software. I can't thank you enough. And we want to let you know Ridge Systems is here for everyone here in the audience, from design to data management to simulation, stress testing, all the way through prototyping and production. We have the software, services, expertise to really give you what you need. Let us know what's on your mind, and we'll do our very best to help you solve it. Once again, thank you so much, Evan, for everything, and we'll talk to you soon.
Thanks, Robin. Thanks, everyone.